We're doing worksheet 1.3. I've done 1 through 8 on a different recording, so this is going to be 9 through the end. Here we go. Come on, Bessie. There we are. So we're going to distribute the 2/3 in. Always distribute to get rid of the parentheses. Maybe I shouldn't say always, but it's usually a good step. I'm going to drop down the minus sign. 2 times 5 is 10. And this is really like 5 over 1. So when you multiply fractions, you multiply straight across. So I did the numerators or the top numbers together. 2 times 5 is 10. On the bottom, I have just 3 or 3 times 1, which is still 3, equals 7. From here, just like we were doing on the first couple of this assignment, we undo subtracting first. So I'm going to add 10/3 to each side. Now here's where we probably kind of need to stop and figure out what this is going to be. So I wonder if I'll do it down here. So we have 7. The question is, what is 7 plus 10/3? We need to have a common denominator, and right now this 7 is basically 7 over 1. So our common denominator would be 3 because 1 and 3 go into 3. And our answer will be out of 3, at least at the start. So we need to convert 7 over 1 to something over 3. Multiply the 1 by 3, multiply the 7 by 3. So what we get here is 7 is the same as 21 divided by 3. And now that we have common denominators, we can add straight across, so we get 31/3. So that's what we have on the right side. Now I need to undo, on the left side I have that 2/3 x. I need to undo multiplying x by 2/3. And you undo multiplying by a fraction with multiplying by that fraction's reciprocal. So I'm going to multiply each side by 3 divided by 2. Red is going to be my only color here, apparently. So 3 over 2 times 2/3, when you multiply across, you get 6 over 6, which is 1. But our x comes down, it's really 1x. Over here, multiply straight across, so you get 93 divided by 6. Now you can divide both of these by 3 at least. I don't think 6 goes into 93, but I know 3 does. Something feels funny here because I get, I get 30. Oh, I get 31 over 2, not 31 over 3. Okay, good. I get 31 over 2, and that's my answer. Ooh. But I'm going to check that real quick. 31 over 2 is the same as 15.5. So I'm going to take 15.5 and subtract 5. So that leaves me with 10.5, which is the same as, well, sure, let's do that. So 10.5, that's what I get in here. Now I need to multiply that by 2/3. So I'm going to take 10.5, multiply it by 2, and divide it by 3. See the 2/3 here? So I get 21 over 7. Sorry, I got excited for the answer. I get 21 over 3, which is 7. So it is correct. Wow, this is kind of crazy. We're doing all these fractions and it's working out right. And maybe I can get this done in the 15-minute time limit because I'm restricted to these YouTube videos of 15 minutes. So distribute here, always, well, usually it's good to distribute first. You could divide everything by 3, but to get rid of the 3, I'm going to get rid of the parentheses by distributing instead. So here's what we have. You know what, folks? This is going to be a quick one right here. So I've distributed. This is what I'm left with. I like to get x to one side, so I'm going to subtract 3x. And right, if you're like saying, well, which side has fewer x's, and they actually have the same. So I get 15 equals 15. So my goal was to solve for x and figure out what value of x makes the equation true. Remember, that's how we've been checking the answers, to make sure that the equation is true with our solution. When you get a true statement like this, 15 equals 15, or 10 equals 10, or x equals x, when the left side equals the right side, it means that there are infinite solutions. If you take any real number, which means it could be an integer, or a fraction, or an irrational number like the square root of 17. When you plug that in for x, whatever you get when you take the square root of 17 times 3 and add 15, whatever you get, you will get the same thing over here. So that's a solution. Any number is a solution. And we're not going to list them all. We're just going to say that there's infinite solutions. All real numbers really work. All right, here, boy, I see some distributing on the left. So we get negative 10x, minus 15 equals. We have some distribution to do here. Be careful, the 2 only goes to what's in the parentheses. So we have 8 minus 6x, and then minus 4x. I brought that down. Now on the right side, before I start trying to undo stuff, on the right side I can combine the x's. I have a negative 6x and a negative 4x. That's negative 10x. Remember to add the coefficients together. So that's where we're sitting. Alright, so now in this equation, I've distributed, I've simplified each side as much as I can. Now I'm going to start solving, and I realize that, well, to try to get x by itself, there's x's on each side of the equation. So I'm going to undo the side with fewer x's, but again, they both are a negative 10x. So I add 10x on each side to cancel out this one, but it also cancels out that one. And now I'm left with an equation that says negative 15 equals 8. So there's no x to solve for. It either means, like was the case in number 10, that there's infinite solutions, or when the equation is true, like in number 10, or here, this equation is not true, which means there are no solutions. There is no number that exists anywhere, no matter how weird the number is, that would actually make the left side, equal the right side. It does not exist. There are no solutions. Number 12, you want to mat and frame. So like here's the picture, and then you put it on a mat. It's like a cardboard type backing or a paper backing to kind of add some color or just make it look prettier. So that's the mat, and then the frame is like the black part, which is usually wood or whatever. So we're doing that to a picture, a 5x7 photo. The perimeter of the outside of the mat, which is the outer black line, is 44 inches. The mat is twice as wide at the top and bottom as it is the sides. Find the dimensions of the mat. So our information is the perimeter is 44 inches. The mat is twice as wide as it is long. I guess like the sides are kind of like the length of it in a way. All right. So we know about the width. The width is something. What we don't know is, I'm going to call this the length. We don't know about the length. So we need to define our variables. And you take the value that you know the least about, which is the length here, and you call that the variable. Then check this out. When we talk about the width, they tell us that the width is twice the length. It's twice as wide at the top and bottom as it is at the sides. By the way, we're trying to find the length and the width. Those are the dimensions of a rectangle, or base and height. People say length and width. So I know the perimeter equals 44, but keep in mind the perimeter is the length plus the width plus the length plus the width. And so the perimeter equals, the perimeter is 44. So I'm going to substitute in 44, we're talking inches, for P. And I'm just going to substitute x in for the length, and 2x in for the width, and x in for the length, and 2x in for the width. So now this equation only has one variable, so I can solve for that variable. Remember, there's 1's in front of the x's, so it's really 1x plus 2x plus 1x plus 2x. 1 plus 2 plus 1 plus 2 is 6x. So when I solve for x, which represents the length, I get 7 and 1/3. 7 and 2/6, 7.3333 repeating. and this is inches. So what does x represent? The length. The length is 7 1/3 inches, and the width is going to be twice that. Remember, the width is 2 times whatever x is. So that's going to be 14 2/3 inches, which is or a quotation mark right there. And then, like, we got to make sure this works out. So if this is 7 1/3 and this is 14 2/3, when you add that together, you get 21, and you add the fractions, you get a whole inch. So you get 22. So if that green part's 22, and this red part would be the same thing, that's going to also make a 22. 22 and 22 is 44. So it works out, and the width is twice as long as the length. So it meets all requirements. Those are the only values that would make that happen. So this has got to be the dimensions of our photo. And I think that is it. Wasn't that fun?